Okay, hello everyone. Welcome to another Wolfram Language Design Review about our new finance functionality. And today we talk about Monte Carlo. This does not sound like a promising name for a function. Okay. Okay, so we have time series, we have financial series. I assume we have Gosha in this meeting, right?
Yes, sir.
Yeah, okay.
And also James.
I'm sorry?
James also James,
as well. Yeah. So the idea of the extended is that you have some baseline and you're projecting it forward into the future. So it's extending in the time domain and it's going to go multi-paths from where you start. So you're not just simulating one forward path, but many. So you have a sample and forward from the past. That's what extended is supposed to mean.
Okay, so back in the day, we had the, in my opinion, not very good design of temporal data that we tried to, sort of put time series on top of. How does this relate to temporal data?
Somewhat, but not exactly. So here, extended time series, you simulate the future, but your time sampling, so your timestamps are all the same for all the paths. Temporal data stores the multipath objects, and you kind of think that each path has its own set of timestamps. So this is, in a way, this is more specialized, because you creating different values for the same sampling in time.
But in temporal data, we have all kinds of Ito calculus stuff and all that kind of thing.
Yes.
Is that going to be used here?
None of this is using the continuous time element of temporal data. It's all discrete time steps, which are meant to go into a financial tabular or something like that, where the timestamp is a row shared across all the paths, as Gosha says. So we're not using the fact that you can go infinitesimal in the time domain, but you can specify the foot to be anything. It's just that foot is going to be the same along all the paths.
I get it, but isn't it the case that people want to use Ito calculus to do, calculations?
They want to do Ito calculus whenever they can do something where they are solving exactly for something which has a symbolic form. The whole point here is because we're simulating, we're not doing that. So we're not going down to differentials. We're just simulating with discrete time steps so you can make as fine-grained as you want.
But just like all of our numerical computation stuff and symbolic computation, those two things should dovetail with each other. In other words, if there is, go ahead.
I mean, you're right that there could be more done to have some of the continuous time things be translatable into this. The main thing we're trying to do here is just all of the things which people most commonly want to do with the discrete forward simulation for finance.
All right, so let's take a look then.
And by the way, I just should say that the principal reason that people reach for Monte Carlo methods is precisely because they don't have a smooth symbolic form that you can integrate in a way.
Yeah, right. So, but in limiting cases, they do, and those things should fit together. Okay, so this is trying to take a time series and it's trying to extend it. So I don't quite know why it's called extended time series. Why isn't it called extend time series?
We were doubting. That's why it's a question for you. That's the first thing. Maybe extend time series more reasonable.
All right. So, I mean, because that's what it's doing. It's returning a time series, right?
Yes.
Yeah, this is purely a language naming convention about whether or not you have function names that are verbs to the things they do, or that are the resulting object that you have as the thing coming out.
I know, but we don't have a resulting object. The resulting object is a time series.
Correct.
It is a multi-component time series.
It's using the fact that time series now takes lots and lots of columns for the same
right.
timestamp.
But so actually, I don't really like the word extend, because this is really kind of tarot cards or something. It's I mean it's a guess the time series. Now
it's a simulate. And I mean, you obviously have things about predict and things like that, which try to get single forward paths from models, whatever. We're not doing that here. The whole point is that the forward model for the simulation is controlled by a few options, but these are mostly Monte Carlo methods. They're all random walks. They're not the random walks.
What is time series forecast?
This is forecasting the values where you have actually model. So you have a time series model, time series process. So again,
Yes.
you actually you start with some kind of a model, and then you have the data, and then you would like to know, okay, if I have this model and I have this data, what is the what is the future value that I can compute? And
Right.
3 is the
So
number
really,
of steps.
what you have here is you've got these various methods
Right.
here,
Which are
and they're like
substitutions
the
for a
first
process.
argument of
Yes, they're
time
like
series
right.
forecast.
They're like a process. Instead, you're having, am I using empirical or smooth changes? Am I using, those are empirical fits, or you can have a log normal fit. Do I want the way that trend is being handled to be that it's mean reverting around the trend, or you ignore the trend,
Okay.
and all that kind of stuff.
All right. Okay. But basically, in this case, it's a more raw armor process or something like this.
Exactly.
Right?
Correct. Mm-hmm.
Okay. But the idea is the same. But time series forecast is returning single values.
Yes. I mean, you have options. But
yes, single values, and you can have multiple steps, but yes, it's gonna be a single value.
It's a single path. It's a single path.
Yeah.
Yes. You have to map it if you want to sample.
Right. Now, what this is returning, this time series, what is that? Does that have bands or something in it, or what does it do? What is it, or does it have multiple columns?
It has
different.
It has lots of columns. It has columns for the full sample size, so you can preserve the whole sample, as well as things for quantile things. But fundamentally, it's giving you a all the different forward paths in the sample. So those projections are based upon quantiles of those from that sample.
And what's this? Is that the median?
Yes.
Yes.
Okay.
And like here this is called simulated paths, but it's in the single time series. So these are really components if you want to use the language of the time series. But in the finance language, there will be paths that your process can take, your data can take. So I think this is so just keep in mind that this is all for the same kind of timestamps that we have these values.
And it's the same time series object. It's just got the values are all the same for the part in the past, and for the future, they're all different.
I'm sorry, but what happened if I took a time series that was just a financial series that was, basically high-low close type data, for example, right? And then I project it forward. Do I add 300 columns to my time series to represent the different paths, or what am I doing here? Do you understand what I'm asking?
No, when you are selecting the closed time series, then you created a new time series object that will start from the end date of your time series until the ending date you decided. Like in this context,
so the extended time series thing is just doing the part from.
No, this is the answer to my question. What I just did is the answer to my question.
Yes.
So this is what you did, and you called it component. You didn't call it path. You called it component. But that's right.
Yeah.
This is, so what you're doing, I don't understand here. So what's going to happen is the components are all the same for the existing, whatever it is, for the existing thing. But I don't know, it's gone 15 days into the future.
So good. The extended part is returning the future part, right?
Okay, but this isn't really okay. So what we've got, this doesn't seem right to me. Okay, look at your plot down here. Okay, you have this time series is definite. Then this is multiple paths.
Correct.
Okay? Now, simulated paths, I don't understand. How did it get the past history? Look here. This doesn't have. Well, I don't understand this.
So the display function down below is calling has more things passed to it, right?
So the historical time series, it's stored in a meta information, and
but that's no good. That's not a good idea.
So that's exactly the question that we have here, because this time series that you're looking in output 691 is just the future. That's what
I know.
What is most
I don't think it's the okay.
So there's other stuff there in the object, and you're right. You could have a design where you still have all the components, but they're all equal to one another for the past, which can be cumbersome to work with because you're making more than you need. Or you can have it that you have the place where it's single valued as a separate thing in the object.
Okay, all right. So let's just understand what we're trying to do here. So we've got the first question is, should this multipath time series, because I can imagine a case where, like, let's say it's high-low close, right? Then this just doesn't work.
Because this is designed to work on a single thing, like the closing price, right?
I know, but I'm asking, what if you wanted it to work on multiple things? Then this design would blow itself up. Well, James, can you comment on this? Have you looked at this design? This doesn't make any sense to me.
The reason why
I mean, and that is an issue we discussed, but because we were just sort of in the applications, we're using like adjusted close here is getting extended.
Yeah, I know, but this is not the right design, right? So the problem that we have, okay, so in temporal data, how do I generate some temporal data?
I'm going to slow down for a second, right? Because the things when you have multiple components, right? If you have to model all of the relations between those components as well as the paths of the central series, you're just giving yourself a massively general and complicated problem that you're not going to be able to get a
I know. I realize this. You're going to do it probably one piece at a time. Although the high-low close, what's that?
You can't do it one piece at a time. They're too strongly cross-correlated.
Okay, so you're saying that the technology you're looking at here is for single component extension.
Yes.
Okay. So financial series doesn't have single components. How do you tell it which of the high-low close to use?
No, that's why you're choosing one of them. You have to decide that, like when you say financial series,
the default for anything which is coming from financial data is to use adjusted close. But if you've got something other than that, you have to tell it what you want it to simulate it on, right? So here you're seeing that the property that you want, which is the column name of the financial series that you want to simulate on, is you're specifying it. There's a default of if adjusted close is there, it's going to use adjusted close. If high-low open close is there, it's going to use close. And obviously you can have close not on daily, but on any timestamp for any time period.
Okay, look, I am wondering whether this should simply be called Monte Carlo time series. Because it's a rather special thing that you're doing, that you're generating many paths, right?
Yes.
Yeah.
And that basically it takes a time series that has to be a single component time series, or it says you're out of luck, right?
Mm-hmm. Mm-hmm.
Now, the return time series does time series have metadata to the point where it could? So let's imagine we called it Monte Carlo time series.
Yep.
Because people think of this as Monte Carlo method, and it really is. This is quintessential.
Yeah, I think Monte Carlo time series is fine in place of extended time series. It is specialized, and the name is fine. I have no problem with it.
So fine. So then what it would return, Monte Carlo time series, and then DT more or less here. Those are its arguments, right?
Yeah,
that's what it needs. Now, doesn't it need to know how many paths to generate?
Yes, there's a default there. The third argument is the number of paths. It's got a default, but
okay. Then, to me, this should be called path 1, path 2, path 3. I think. If it's really going to be Monte Carlo, if that's what. Okay. Now the next thing is what the model is. And following the time series forecast idea, the model. Okay, so these are just method options, is that right?
Yes, there are method options, including accumulation method options, which are basically all of these are random walks of one kind or another with a marginal distribution, and you can either have arithmetic or geometric walks, and you can do all kinds of things to determine how you're getting the change distribution from the past.
Okay. So in our random,
as well as how you want to handle trend.
I got it. So, in our previous random walk methodology, right? So we have random walk process, right?
Mhm.
How does that relate to, things like a mean reverting walk? You see what I'm saying? So in other words, I should be able to interoperate these, I should be able to put a random walk process into Monte Carlo time series. You see what I'm saying?
But
Yeah,
that's the random function right? So random function takes the process, the model, and then you give the time, the domain for the time for the simulation, and then the number of paths.
Okay.
And what it's done here is that this is somewhat non-parametric simulation. So you find like non-parametric methods. So this models kind of, right? So you operate on the data only, and try to, figure out how to simulate from that, but you don't give the parametric model explicitly. And so for that, to simulate from random walk, we have the random function that does that.
Yeah, but do they interoperate? In other words, if I wanted to use a model that came from random
It's a good
function,
question, and the answer is right now they don't. There's only these method options supported. It's not supporting any random walk process in the
I got it.
method.
So, but a mean reverting walk or a log normal distribution, these are both things that could exist in the random process world, correct?
Sure.
And so, okay.
And slight modifications like, the no arbitrage idea, right? Those are special to the financial world, right? But they're just special method options for how to handle the mean or the trend part.
I'm not buying the method arrow and accumulation method arrow. I think about this for a second. Now this isn't right because simulated paths, oh, for God's sake, you're hiding the original time series in some weird metadata? Is that what's happening here?
Well, yes, the original
So
time
that
series
isn't going to work, is it? That's a bad idea.
So the reason why we are just storing the original data in the metadata is
it's a hack. You know that it's a hack to store it in some invisible piece of metadata. You know that's a hack.
But
right?
usually we don't need it.
James, you should not have let something like this through. It's a hack.
Yeah.
Okay, so why did that come to me? It shouldn't have gotten here. This should not have been, this should have been stopped at a previous level.
So the question is, so that's kind of one way. But the question is, how general this extend time series can be thought. Because if you just think about extend time series, giving a time series without any reference to, finance, or anything, these models can also work, right, in a way to extending that. And so our question kind of here is also like, could we think about this, as a more, general function, as we are extending time series with some method, right? But so then the thing is like, so then right now it returns the time series, which is like nice object. But then if we want to, store the original, data, then it would require creating a new object for that.
I know,
which would make it more special,
I realize
right?
this. I'm already many steps ahead of that, right? As you might guess.
Yeah.
Okay. So the issue is, right, in what we have previously is, things like the armor process stuff and so on, right? And so let's understand how to merge that with this. Okay. So I don't know whether the right answer is going to be something closer to temporal data from time series, or whether the right answer is going to be what you're doing here, which is to break apart the forecasted part from the non-forecasted part. And in these plots, to have to feed in two things, okay? Because it's not going to work
to have metadata. I got it. Yeah.
To have a little hackaroo there.
You either have the object come back with the source data prepended, or you have the display function receive two objects.
Right. And one possibility would be that that we name these things, future path 1 and things like that we have. I mean, why don't we use hierarchical keys here and say, existing data and simulated data or something. And those are
because the timestamps are different. So they do
not. I know they're different. So
So the
it's missing.
it's
Existing
missing.
data is missing for the future. Simulated data is missing for the past.
Okay.
Mm.
It just looks awkward. You're gonna have the whole table of missing.
That's right, because you're not going to ever look at this table anyway,
Okay.
right?
If this,
Do you
yeah,
like
this
that
is
better than passing two things? Because I like passing
I,
two things better.
I
Yeah.
think, I don't know. I think this might be very nice to be able to have a single thing that you can feed to that forward paths plot, for example. See what I'm saying?
Mm-hmm.
And I kind of like the idea of, I mean, the question is okay, when you have your various financial valuation functions that work on a time series, right? What should be the case is that on this Monte Carlo time series, let's say you've got all those expected rate of returns and all, I don't know what all of them are. We've gone through some of them, right? Presumably on these predicted time series, you should be able to just apply that function, get something which instead of giving a single
Sure.
result gives a distribution. Do you have that stuff wired up?
There certainly are things we have which are calculated only on the distribution. That is they only work on the multi.
No, I understand, but some of the previous things which you thought you had a definite time series. So, for example, here, financial options, right? You've got, well, it's a bad example. Let's say, this financial series thing.
Yeah, I mean, any of the thing, most of the things you can do on a single thing, you can definitely do on a single component for sure. But the places where you typically need something which is more calculated is precisely when you're looking at effects across the sample. Like if you're trying to put an option on it, right, where you have to do some max of X and 0, right, or min of X and 0
exactly.
applied to every path, right, and that's exactly a typical application of this. But all of those operate only on the sample, not on the individual path. That is, they have an operation on the individual path, but that's trivial. The calculated part is
okay. So here's what I predict:
them.
if we have something which has both past and future in it, there will be really cool things that we can do, like with backtesting, for example, where you roll it back to the point where you have the series, right? And then it becomes a definite answer. You roll it forwards, part of the series is known, part of it is not known, and then it will
you want to start doing multi-valued at the point where it breaks from past into future.
Yes, and I think that will be very nice.
It's complicated to implement though too.
Well,
I mean, there's lots of things. There's lots of things that you want to do only on the place when you've got the sample part of the path.
I understand. So, but okay.
I don't disagree with you. There can be tighter integration here with some of the past temporal data things, and certainly the two objects with that are each simple time series, the new form of multi-component time series, or one thing with a lot of missings is a design option to consider. But
yeah, okay. But let's walk this forward a little bit. Okay, so the question is, if we did that, of having existing and simulated, right?
Mm-hmm.
Then every function that you've implemented that computes things would eventually start computing things that could include simulated data. And then it would return things like a rounds and so on. Am I making sense?
Yeah.
Now, I mean, do we want to sign up for that, or are we not? Is that I mean, the alternative?
I mean, I can tell you what we've actually implemented so far, right? The farthest thing we've implemented so far is when you have these whole samples, you can get like empirical derivatives like you would have for an option. You can get its Greeks, right? And we've pushed it far enough that you can do that, right? So you can ask for the first partial of the value of an option on this path with respect to the price or with respect to the time remaining and so on, right? And that's using the direction in which you're moving your differential is across the sample.
Right. Hey, listen, here's one fundamental problem. The word extend is wrong. Okay. If you're just going to give the future, don't call it extend, because extend suggests you take what you have and you extend it. See what I'm
I
saying?
understand. If it's only making the future, that's why we had extended. But Monte Carlo time series, I think, is better. But
well, but I think that what one wants is something more like this. That what one wants is, it isn't the right word, isn't extend, and it isn't really, and it's not really forecast.
we used simulate before, but
well, I think that that's too general. Monte Carlo simulate applies to, millions of areas in physics and things as well.
And it's
So
kind
that's
of
not
it's synonymous almost.
for what?
you're saying Monte Carlo
Simulating and
already means
Monte Carlo.
simulated. Yeah.
What did you call this? I think, Filippo, forward paths or
We call the original simulated forward path.
forwards, yeah, forward. But
Yeah, simulated forward path was the original name of this function, but it's gone through multiple reviews since then.
Well, it's the extend is out of the if it's called extend, it's got to include what's there already, and it's not obvious to me. I mean, then what you've got to do in this function is then give it two things, right?
Yeah.
There is a down value. So the historical time series is basically at the moment only used in displaying function. Like you can see the second down value, you can put the simulation that it comes from wherever you want, and the second one is the historical value. Now the function extend time series, we are hiding the historical data. It's inside metadata, so we are grabbing for free, but because it's coming from our extended time series. But if we're removing, there is no problem on displaying.
Yeah, some of these ones here are examples where you have to simulate multiple series to get drivers for something more complicated. This is just integration across the rest of the package.
Okay. All right. Okay. All right. So the key thing is, I mean, what is the thing that's being returned when it's the multipath object? What is that thing?
Right now, it's a time series.
No, I know that, and it's fine for it to be a time series. But what is that conceptually?
Conceptually, it's a set of possible paths. It is
right.
Possible paths which are continuations of the past.
Or forecasts, but I don't like forecasts because they're not really forecasts; they're just simulations.
Yeah, and it's the whole distribution that you care about rather than a single one. So.
I mean, I'm wondering, where do we have this? Ooh, where is it? Sorry.
Are there other places in random function where other terms are used for this, like sample or something like that?
Well, simulated paths.
No, but what do you call it in the random function stuff? It's called a process here.
Right.
On the process is the driver.
Yeah, so on a process side, you have a path, which is a realization of the
process. Yeah.
And so when you have the many paths, you just have many possible, realizations of the process.
But you don't have a separate name for the thing with many of the realizations.
No.
Well, okay, so we got this notion of an estimated process.
Sure, that's where you're using data to fit what the process parameter should be. We use that inside for like the mean reverting walk version.
Okay, but so in the end, this returns a process here.
Yes.
And it should be the case that you could feed into this time series maker, you could feed one of those processes. See what I'm saying? Take that Poisson process and just feed it in to this function. Right, so this is, what you've got right now is the forward paths from this, right?
Yeah.
But if you just took this Poisson process, I don't know if that makes sense. But I mean, in other words, you take forward paths of the Poisson process, comma dt, would that make sense? In other
That
words,
means
you
you
fit.
don't.
What's that?
That means you don't care. There is no historical value. It's just like the
That's
creation
right.
of the
There's no
process.
you already extracted the process from the historical data, or you got it from the moon or something. Who knows where you got it, right?
And that would be the same thing as the random function is doing.
Yes.
Well, then
random
let's
function.
walk through that. What does that mean? What's the relationship between random function and this time series?
So random function needs a model for a process. So
Yes.
the missing kind of step that it's between random function and this Monte Carlo time series is that we go from the TS, so from the time series data, find some kind of a model, and then simulate. And this model doesn't have to be, estimated process, right? From what I understand, we can use the distributions, on the differences of the values.
Yep, exactly. So the point is that whereas one of these possible processes, even if you find its parameter values by estimated process, is always an actual formal object for the DT, right? Whereas by comparison, these things over here are much more the bootstrap method of the past, right? You are doing something where you're deciding what to extract or keep from the past to determine effectively your DT model, but that DT model is usually, it's the empirical distribution, it's a smooth kernel distribution over that empirical distribution, or it's some fitting of that. And then that's just for the changes. And then for the trend, you handle that separately.
What is this? Oh, paths 1. How do I get multiple paths here?
To the random function, add one more argument at the end. So after 50, there's the comma, and say 3 or the number of paths that you would like.
Oh, how interesting. Look at that.
Because if the temporal data doesn't have the names, in a meta information for the paths, this is the default naming convention.
Yeah, that's fine.
Yeah,
but I mean, but the whole point is it's very close to what. Okay, so the only difference here is that in what you're trying to do here, you have actual real world, anchored to the moon timestamps, whereas here it's just theoretical, right? 1, 2, 3. Makes sense. So is it the case that temporal data is now internally using tabular?
No, temporal data is not yet using tabular.
Okay, but the good news is it is interconvertible in this way.
Yes, it is.
Right?
As long as you have discrete time steps that you're going for sure.
What does it do if it has continuous time steps?
I mean, step implies you've discretized it, but you can have the process.
No. The time column gives you your timestamps. So this is just the leftmost. It's just the row enumeration.
Yes.
But you can start your simulation not from 0, but you can start from 5 to 50.
For sure.
And so the
point that I'm making is just that the process here is not as forced to be as discretized in the world of random function.
Yeah, I know, but the thing that's generating from this random function is discretized, correct?
Well, so yes, because even if you take the continuous time process like Wiener process, you're gonna sample on some timestamps. So you're gonna have a discrete sampling.
Yes.
Yes.
It's just that's outside the level of the process itself. The process itself has a symbolic form that doesn't have discretization built into it. It has.
This needs the third argument in the time because it needs the step. So you go from 0 to 50 and you have to provide the step in which we are sampling.
Yep.
Okay, so by the way, fix this error message.
Whatever.
Fix the error message. Fix what it's, give it an error here. You see what I'm saying? Give it something where it tells you that's a continuous process. I don't know how to do this.
Yep.
Does that make sense? So that's for
in
Gaucher.
the random function, yes.
I got it.
That's for Gaucher.
I see.
Okay, so now look, the good news is this is really not incompatible with what you're doing up here, right?
Yes, agreed.
So the difference. So I think what has to happen You know, it's almost like it's a random oh my gosh, what's it called? Random variant. What do we call it? The random instance that we get in random variate, right?
Random
This
variate is the simulation of the distributions. Yes.
I know, right?
So,
But this is kind of random function is kind of the, you know, each time slice is a.
yes,
I mean, it's very
it's a
weird
distribution. Yes.
that this has a thing called time when it has a random function. See what I'm saying? Because it could be a random function in space and wherever, right?
Mhm.
So
This
I
is
think there's some redesign that's needed on this stuff as well. But let's go back to what we're dealing with. Okay.
Yeah, you're right. And the pure process things could be in any
I think
dimensions. It doesn't have to be
it's
time
kind of
dimension.
thought about random function because you look at the path as a function of time, because
I
for
know
each
that. I
time
know
you
that, but
have
there's
a
nothing in the name. It's giving a time column here, even
Yeah.
though that's not in the name. Okay, but so let's look at what.
Sorry, but the time column comes from the conversion to tabular, so that's
Okay,
a
fine.
different, so
Okay, that's
we can
different
change
level.
that. We can we
Yes.
can
Okay.
change
All right.
that.
But but is it documented? It's not documented here. The conversion to tabular is not documented here, which is wrong.
No,
Right?
it's documented on the tabular, but I
No,
can add
no.
that
But it's
here.
obvious they should be here, shouldn't it? Right? Obviously,
Yes,
should be
yes,
here.
yes.
Okay, so it's
We will
wrong.
add
So it's a
this.
bug. So you'll fix it.
Yeah, we add this.
Okay. All right. Okay. So let's go back here. There's an incompatibility because you've got process as a first argument here. Whereas here, how much of the time do people say, I want a blah, 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 and how much do they want sort of an automatic thing? What is the automatic thing?
I think the currently automatic thing is smooth chain distribution with no other arguments.
Is that reasonable or is that
Yes, it's reasonable.
Okay.
The most common reason people reach for this is because they want to use information from the past to get a non-standard marginal distribution. That's why they want to simulate in the first place. So
okay, but fine. But there's a reasonable default here in a way that there probably isn't for random function. Because random function, the main event is the process there.
Yes.
Okay.
Correct.
And here all the extra options are, have to do with the kinds of assumptions people want to make about what's realistic in financial markets, but that's what the extra things about trend
fine.
are.
Okay, so now what we got to do, we're trying to return a time series with multiple columns, okay, which possibly should be a different head. Okay, it should possibly be a multipath time series or something.
Just like you have to simulate. It obviously fits into a time series object in the new time series format, but you're saying it should still have a different head because you're going to do different things with it when the different components of it are actually different realizations of just possible paths.
That's what I'm thinking. I mean, I might be wrong.
It's not a crazy idea. Not a crazy idea. I mean, we were trying to exploit the fact that it just fits as a time series.
No, I know.
But we certainly have plenty of functions that we do on it that require that some of those columns are different realizations. Like if you're doing an expectation across, options or something, it requires the extra columns are understood to be different realizations of a possibility.
Well, so that would be multipath time series, basically.
Yes.
Just like temporal data, right?
It is.
Because the difference is that, in the time series right now, you assume timestamps are the same for all your paths. So you have only one set of timestamps. Yes. And in temporal data, you can have different timestamps for each path.
Yes.
Mm-hmm. Well, the question is, should this return temporal data?
I mean, you get so much by having all of the times uniformized.
Yeah. No, I understand that, but it's a special case of temporal data, and it would be easy to flag that special case. Question is the structure of what gets returned here.
I mean, I don't mind a different head for something which is the special form of temporal data where all the times have been made compatible with one another, and you could therefore do a lot more things with it, including with the new tabular, et cetera, functions. So I don't disagree that it should be easy to go from a temporal data object to one of these things.
Yeah.
We even have functions like, time series conform, whatever, that are designed to do that.
But if you use time series head, it's gonna indicate that you're gonna have a common
Exactly.
timestamps. So this already hints you that everything is sampled uniformly. So all your
Yes.
values are always lining up. And that's very important for your computations, because you don't have to do any resampling or anything like that.
Exactly.
For temporal data, it's like it's a bag of paths, and you have no idea whether they.
I agree.
So,
I agree.
Look,
so temporal data is different. I'm just saying
time
that the extra thing wanted is just an easy way from temporal data to force the resampling on a particular foot to make it into one of the.
All right, I got a suggestion here, guys. Okay, so with multipath time series, one of the things that could be done is that there could be extended keys here, so that if you in fact wanted two different things to be simulated, like high-low close, for example, you could then do that.
Yes.
Okay, so then it becomes, you're taking a multipath time series, and maybe you're giving a time series here, and then you just give dt. Well, is this the right thing? And then, no, that's not right. It's something that generates a multipath time series.
So the Monte Carlo.
Yeah.
Or the simulated.
Well, multipath.
But again, the multipath time series, it's kind of confusing because what you have is just different components, and this is how this time series is structured. So you don't have to, I don't know why necessarily calling it multipath. Because if you add extended keys, it's still multi-component time series, and you can still have.
All right. Well, maybe the answer is that it could just be a time series, but there could be some metadata that causes its blob to have something different shown. Do you see what I'm saying?
Mm-hmm. So basically, if you click the plus, then it could give you the information about the keys and and
well,
the counts.
It does have this one here, but I think it should be something that's indicated before the fold.
So that means that you would thinking about different summary box for this case?
Yes. Mm-hmm. That we would somehow know that it's that it's something. I don't know how we know that, which is a problem. By the way, I'm going to have to go in 4 minutes. So we will probably have to continue this.
Mm-hmm.
Okay. So fundamentally, look, I think this is probably the right thing, is to do these, it is probably it should just be a time series, but somehow indicated here. I think it's really confusing to not indicate it here. And maybe there's some convention for time series keys for this multipath case. Maybe Gosha and others could think about that. Does that make sense?
Mm.
Yes, because maybe you're thinking, about kind of showcasing the extended keys, that would give you the split into the groups or something like that.
Right. You use an extended key, so you have the original time series, and then you say, I wish it wasn't the word extend. I mean, we could call it multipath predict.
Project.
Simulate.
Yeah, simulate is. I think project is too easy to misread as project.
Fair.
I don't think this is terrible. Multipath simulate that returns a multipath time series.
Yeah, that's not bad.
And then here, so long as your generic method is not completely stupid for time series that aren't financial time series. I think it isn't totally stupid, right?
Yeah, it's fine. I mean, especially with some of the method options, we definitely used it for things which are they're used in the finance package as predictors of things, but they're not underlying,
All right, I am
financial.
provisionally thinking this is pretty good. And then whatever the name was here, that becomes the extended key name, right? Whatever the name of the thing was. So multipath simulate, if this time series had multiple components, it would presumably take all of them, or you just give it component there, but it would take either that single component or a list of components here. And those are the things that will be returned in the new time series, right? As extended
Yeah.
keys.
Right.
Yeah.
With the caveat that they are going to be independently simulated.
For right now,
Yes.
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 For right
Okay.
now, that will be the
Mhm.
case. Maybe in the
okay.
future it wouldn't.
Yes.
Um,
Exactly. Yes. Mhm.
Okay, I think this is not a bad design. And then with respect to the simulation method, I tend to think that it should be an association, because I think that it could be what is this? This is the something method, and the other one is the accumulation method. What method is that?
It's really about the marginal or change distribution. That's why they all say change
It's the
distribution.
question whether we take differences on the data between the timestamps or whether we take ratios, right? So
That's the last
geometric...
one. That's
change
the accumulation
distribution, and then it's something. Okay, this needs names, and the question is, where is this going to go in the argument structure here? So right now we've got the time series dt.
So let's be clear. Right now, there's three things that are being done in method. There's the accumulation method, which is just arithmetic versus geometric. Then we have the change distribution specification, and then you also have things about how to treat trends, which is not quite the same as the change distribution.
So it's an association. It's going to have a pile of crud in it, basically. And then, right, so these are things, right, so this is functions on the multipath.
Yes.
On the time series.
Extract quantiles and so forth.
All right, we're going to have to continue this another time. I think we've made some good progress here, but I'd like to understand what is the argument structure here to get. I mean, it feels a bit wrong. Well, let's see. Normally, you have the time series and a DT, right? So why not put the method first? Why not put the method association first if you need it?
And then the data after that, you mean?
Yeah, because then it will be the same as every other function that has, method for, has the action to take. And if this ends up being an ARMA process, right? Imagine that we had a thing where that was an ARMA process, then that would all fit together.
I like it. I think it's workable. We might have a little bit work to do to make sure that we can do that for some of the other things, but it shouldn't be that hard.
I think this is the right way to do it. Okay, so then what we've got to do is, how do we take a multipath time series? Can we have a little think about whether we can get some tag into the summary blob? Okay.
You mean even if the head is time series, there's something in the time series itself that tells the
yes,
summary box.
That's some way to some metadata thing, something that indicates that. Okay.
Because that would need to kind of work in general for time series, right? So
yes,
we need to kind of think how to design or redesign the summary box, that if that object is present, then we will include it in the summary box.
Yeah, there's some if logic needed in the time series summary box to pop up extra pieces.
Yeah, because then I need to kind of read it off, right, and check if it's there, and then have the two versions of the summary box.
Yes.
And the question is, what do we want, right, in this second version?
I'm sorry, I spaced because I got to go and do my thing. But
yeah, we're just talking through what might be the things that the summary box would add in the multi case. Like
I think if it just said how many paths it had.
Well, it might also have the column name that it went multi on.
Yes, okay, that would be good
too. Okay, I'm going to disappear.
Yep.
See you folks on the live stream. Bye.